All right, let's dive right in. If you're building anything with AI right now, you are staring down one of the single biggest decisions you can make for your whole system, picking the right brain for your app. So that's what we're going to do today. We're going to break it all down. And by the end of this, I promise you'll have a super clear framework to make that choice.
Look, we've all been there, right? You ask your fancy new large language model a question, and it gives you this incredibly confident answer that is just completely wrong. Or maybe it's using information from 2 years ago. Or my personal favorite, it just makes something up out of thin air. It's so frustrating. And look, for any real world application, that's an absolute deal breaker.
So why does this even happen? What's going on under the hood? Well, it really boils down to two big problems. First, these models, they hallucinate. That's the technical term for, well, for them just inventing stuff. And second, their knowledge is basically frozen in time. They only know what they were trained on, and that training data could be months or even years old. They literally have no clue what happened last week, let alone yesterday.
Okay, so how do we fix this? Well, thankfully, there's a really elegant solution called Retrieval Augmented Generation. We just call it RAG for short. Now, the absolute best way to think about RAG is this. It's like giving your AI open book notes for a test. So instead of trying to answer just from memory, its old training data, it gets to look up the answers first. It can access fresh, up-to-date, even your own private data before it says a word. But, of course, right? We solve one problem, and a new one pops up. To make this whole RAG thing work, you need a special place to store and, more importantly, retrieve all those notes. You basically need a new specialized brain for your AI. And that, my friends, is where we hit the vector database dilemma. So what exactly is a vector database? Think of it as the heart of the whole RAG system. And here's the magic trick. It doesn't just search for keywords like a normal search engine. No, it searches for meaning. It's like having a brilliant librarian. You can ask for something about, say, corporate profits. And this librarian is smart enough to know you probably also want to see stuff about revenue, shareholder value, and profit margins. Even if the exact words corporate profits aren't in there, it understands the concept.
And here's the problem. The market for these things has absolutely exploded. Suddenly, there are dozens and dozens of options. You've got Pinecone, Weaviate, Chroma, Milvus, Qdrant. The list just goes on and on and on. It's totally overwhelming. So where do you even begin? How on earth do you choose the right one for you?
Okay, deep breath. What you need is a framework. A simple way to cut through all the noise and navigate this crazy landscape. You need something that lets you make a clear, confident decision. Let's think of it as our selection compass. And here it is. We can boil this entire complicated decision down to just 4 key things. 4 pillars. I like to call them the 4 S's: speed, scale, simplicity, and spend. That's it. If you can figure out where your project stands on these 4 things, I guarantee the right choice is going to start to become crystal clear. All right, first S, speed. This is all about how fast you get a response back. We're talking latency. Think about it. If you're building a chatbot, your users expect an instant answer. They're not going to wait around. A delay of even a second or two can completely wreck the user experience. So for a lot of apps, super low latency is just non-negotiable.
Okay, next up, scale. Look, it's pretty easy to build a proof of concept with a few thousand documents. That's the fun part. But what happens when your app actually succeeds? What happens when you suddenly have to handle millions or maybe even billions of data points? You have to plan for that. You need a database that's not just going to work today, but one that can grow with you. Number 3 is simplicity. And this really comes down to operational headaches. How easy is this thing to manage? Are we talking about a fully managed, press a button and it works kind of service? Or is this an open source tool that you and your team have to host and patch and maintain all by yourselves? You have to remember your developer's time is almost always your most valuable and most expensive resource.
And the last S, of course, is spend, the cost. But wait, this is not just the price tag on a website. You have to think about the total cost of ownership. That includes the servers you'll need to run it, the developer hours you'll sink into maintaining it, and even the potential cost if the thing goes down. Trust me, sometimes a free open source database can end up being your most expensive option in the long run.
Okay, so theory's great, but let's make this real. Let's actually take our 4S's compass and put it to work. We'll take a quick tour of the landscape and see how some of the big names out there actually stack up. Really, at the highest level, You're looking at one fundamental trade-off. It's a spectrum. On one end, you've got the fully managed services, like a Pinecone. These are incredible for getting started fast with way less operational pain. On the other end of the spectrum, you have these self-hosted open source options, like Chroma. These give you absolute control, total flexibility, but you're the one who has to manage it all.
So let's see how this plays out in the real world with a few of the big players. Take Pinecone. As a managed service, it is laser-focused on speed and scale. I mean, it's built from the ground up for massive enterprise-level apps where every millisecond counts. It's also super simple because they handle everything for you. Now flip all the way to the other side, and you've got something like Chroma. Its big win is simplicity, for a developer to just get started and spend, because it's open source. It's awesome for getting a project off the ground, prototyping, or for smaller scale stuff. And then you have companies like Weaviate sitting somewhere in the middle, kind of a hybrid. They offer an open source version, but also have enterprise features, trying to give you a balance of all these factors.
Okay, so we've looked at the framework, we've looked at some examples. Now we get to the most important part of all. How do you take all of this and find the perfect fit? Not the perfect fit for some big tech company, but the perfect fit for your project right now. So that brings us to the big question, right? The one everyone asks. Just tell me, what's the #1 best vector database? Which one is it? The absolute king of the hill? And the answer is the best one is the one that's best for you. I know, but it's the absolute truth. There is no single best one. It all depends on your priorities. Think about it. Are you a tiny startup just trying to build a quick prototype? Well, simplicity and spend are your kings. An open source option like Chroma is probably a perfect match. But what if you're a huge company building a global customer service bot that can't have any latency? Then you're going to pour everything into speed and scale, and a managed service like Pinecone is probably the right call. See, the compass doesn't point to one treasure, it helps you find your treasure. So here's what you do next. A simple 3-step action plan. Step 1, define. Sit down with your team and literally rank the 4 S's for your project. Be honest, is speed a must-have or a nice-to-have? Step 2, shortlist. Based on that ranking, pick 2, maybe 3 databases that look like they fit your profile. And step 3, and this is the most important one, prototype. You have to get your hands dirty. Install them, load up some of your real data, and kick the tires. Nothing, and I mean nothing, beats a real-world test drive. All right, I'll leave you with one last thing to chew on. This whole world of AI is moving at a dizzying pace. Right now, today, the vector database is that essential external brain that makes our LLMs so much smarter. But things are changing fast. As the models themselves get bigger and smarter, what's next? What's going to be the next critical brain that our AIs will need to really, truly make sense of the world? Something to think about. Thanks for tuning in.